Ladies and gentlemen, please welcome back the Director of Development for the National Ataxia Foundation, Joel Sutherland, and the leader of the Spouses Support Group and host of the Did You Know podcast, Dana Morrow.
Here we go.
Hi, welcome back. So, quick poll before we begin. How are you enjoying the conference? By a round of applause.
There we go. There we go.
Okay, great, great. Because we're enjoying being up here. I hope you can feel that. And we are so excited to be back in person after all this time. It's been a long time coming.
Great to see you here. We also have more than another 100 people catching this online via the Chime Live stream. So there's a lot more joining us here this afternoon than meets the eye. 45 states attending this year's conference. 22 countries from around the world also with us. So this is a big deal, and we hope you're enjoying this too, no matter where you might be, all right?
Yeah, exactly. And we also want to just give you a couple of reminders. So if you open up Chime Live, that's your opportunity and place where you're going to put all your questions. And you can enter those questions at any time, so we encourage you to do that. If you're going to have that platform open, we ask that you keep your volume off so that there's no feedback. We also want to remind our virtual guests to visit the virtual hallway, AAC Quest, and the photo booth.
That's right, and for those here attending, be sure to swing through the exhibit hall. Plenty more people to meet within our community. You know, remember we're talking about networking over the next couple of days here. Great folks out there and have some great things to share with you as well. So be sure you go through our exhibit hall. And once again, special thanks to our sponsors who are helping us do this year. Our folks from Reata Pharmaceuticals, from Biohaven Pharmaceuticals, Lacerta Therapeutics, and PTC Bio. Thank them. Let's give them a round of applause for stepping up with us. Thank you.
Yeah. Also want to remind you to post on social media. It's hashtag AAC 2023. And we got an increase in Instagram followers after this morning. So that's fantastic. So if you don't follow us already on Instagram, it's at Ataxia Foundation on Instagram.
There you go. I think we've got most everything there, right?
I think so.
We've got a big afternoon for you. Later this afternoon, you're going to be able to hear from, if you spend any time on our website over the last year or so, and Dr. Susan Perlman, who hosts our Ask the Expert session every month. I'll save a story about Dr. Perlman for later this afternoon, but that's going to be a great session. But first, Dana.
Yeah, we have a session called Breakthroughs in Ataxia Research. And so I'm going to introduce our speakers, and I want to call out that their full bios are in your program, and I'll point you to the page so you can read more about them. But I want to give you a quick glimpse into each one of them. So our first speaker will be Bill Nye. He's an American science educator, an inventor, a television presenter, keynote speaker, and New York Times best-selling author. And you probably know him best as Bill Nye the Science Guy. So he'll be joining. We also have Celeste Suart, who received her PhD at McMaster University. Her laboratory research focuses on the DNA repair of SCA type 1. She'll be joining. And then we have Hayley McLoughlin, who will also be joining. She's an assistant professor in the Department of Neurology at the University of Michigan, and her lab is focused on discovering disease biomarkers for hereditary ataxias, among a host of other things. So you can find their full bios on page 18 and 19. So I'll ask them to come up.
Let's invite them to the stage.
We're going to invite them up and enjoy.
Hello, hello.
Hello.
Thank you for this opportunity. We're going to take a seat and make this real comfortable for you all, okay? So take it away, Celeste. We're going to talk about breakthroughs in ataxia research.
Yeah, so welcome to the session. We're so excited that you were here to join us today. In the next 20 minutes or so, we're going to go over some of the big advancements in ataxia research that have happened since the last time we were able to gather here in Las Vegas for an annual ataxia conference. So about 4 years or so. And then is the clicker over
I'm
there?
Sorry. I can grab it.
No worries at all. Thanks so much. So before we jump into things, a few housekeeping items, starting with some disclaimers. All of the information that we're going to share with you today is for informational purposes. The National Ataxia Foundation strongly encourages you to chat with your own primary healthcare professional before making any decisions about your health, and any specific research studies, clinical trials, resources that are mentioned in this presentation do not imply an endorsement by the National Ataxia Foundation. Also, neither Hayley nor I have any financial conflicts of interest information to share with you that are relevant to what we're going to be chatting about today. So you may be wondering, who are these people? Why are they giving this presentation? Well, I'm glad you asked. As mentioned a little bit earlier, Dr. Hayley McLoughlin is an assistant professor at the University of Michigan Neurology Department. Her lab mainly focuses on SCA3, where she does a lot of work unraveling the mechanisms and identifying therapeutics for inherited ataxias. And my name is Celeste Suart. I'm a recent PhD graduate from McMaster University in Canada. My research is mainly focused on spinocerebellar ataxia type 1. And you may remember from earlier in the presentations today, I'm going to be joining the National Ataxia Foundation as their new patient engagement manager. Thank you. I'm very excited to working with you all going forward. In addition to those roles and responsibilities, Hayley and I are also the co-founders of SCAsource, which is a website where you can read plain language summaries of ataxia research news online. And if you haven't heard of us, no worries whatsoever. We partnered with the National Ataxia Foundation over the summer in order to increase our visibility. We have over 220 lay summary articles about ataxia research, mainly focused on the spinocerebellar ataxias and RSACs at the moment, but we're hoping to do more on other types of ataxia going forward. We mainly write articles in English, but we have articles in 4 other languages as well. And if you'd like to visit us, our website is on the screen here. If you have any feedback for us, we'd love to hear from you. And if you look at our most recent article that we posted, it's on the discovery of the gene causing SCA27B. So after this talk, you may be interested in learning a little bit more. But before we jump into what we're going to be talking about today, we just wanted to say that everything we're going to be talking about today is not possible without you, patients and family members. So for making all of this possible, on behalf of researchers and clinicians, thank you. So Hayley is going to be giving us an overview now of what we're going to be talking about today.
Sure. Okay, so we were directed by Dr. Moore, the Chief Scientific Officer, to discuss breakthroughs in ataxia research. We're going to highlight the news of the last half decade or so, which arguably has been a pretty challenging feat to put together in 15 minutes of time that we have to sit here and chat with you on. But we're going to cover things like funding and partnerships. And I think that has been a really impressive growth in this field. We're going to talk about treatments. And again, we have an exciting breakthrough that we heard about this morning. We have clinical trial care and treatment trial design that has been just ever expanding and also quite unique because, again, ataxia is unique. And then finally, we'll talk about the research and diagnostic opportunities that have been accruing over these last 5 years or so since we were in Las Vegas before. So let's start with funding, breakthroughs in funding and partnerships. And to get us started, really this comes, I'm going to start with the advocacy or the opportunity that you all have created for us as ataxia researchers. In a way, your voices were heard. So going to the Hill Day and speaking, we now have the opportunity for the Congressional Directed Medical Research Program, this DoD grant opportunity, which expands ataxia research just so broadly. And again, FARA or FA, Friedreich ataxia, has had this opportunity last year and they capitalized. There was many ataxia researchers who applied, and I think there was over a handful of applicants that were awarded the grants. And I was fortunate enough, based on the National Ataxia Foundation, to sit on a webinar and learn the tips and tricks and techniques of this new grant opportunity that many of us ataxia researchers are going to be applying for very soon, in a couple months. Additionally, NAF grant funding has expanded, as we heard this morning, and those kind of grant mechanisms are the bread and butter for what we do. These rare ataxia disorders are a challenge without model systems. We heard earlier this morning that there are 5 new model systems in the last 5 years that have been generated for ataxias. That means 5 new opportunities for us to explore these diseases. Those kinds of grants are integral to creating careers, mine included. I received a Young Investigator Grant Award that sold some of the early stage development of my research platform. And I have now 2 NIH-funded grants and a big kid job, as they will call it, a professorship at the University of Michigan in the Department of Neurology that I couldn't be more proud to be engaged with this ataxia community for. Furthermore, these grants have created opportunities for drug discovery. That drug discovery has also gotten industry involved, very excited, engaged with our platform as an opportunity to see the future. And you heard this morning about OMAV and that pathway forward, which is long and tedious, 10 to 12 years for some drugs, much faster for others, maybe slower for others. It's a challenging road, and it really does take the partnerships and the collaborative opportunity with industry, academics, foundations like the National Ataxia Foundation, and just our patient advocates out there. To move science and all of these discoveries forward, we realize as an ataxia community, as a research community, that we need to organize. And that couldn't have been more clear when I first started in this field about a decade ago. But it hasn't been until the last few years that ataxia global initiatives have been created. And this is one of a few that are out there, but this is an established international collaboration that is there for the development of ataxia treatment. And some of the goals of AGI is really to promote open data source sharing, which that's why I'm in this field. This is an awesome research program, an awesome field for engagement and collaboration, and it just feels like a family. And because of that, we don't sit there and hide our data in our laboratories. We share, we engage, and we create opportunities to move this field forward. I personally serve on a working group through AGI for the Biomarkers Core. And we're going to be stockpiling biomarker samples so that we have access to be able to interrogate these for natural history studies. And as you heard earlier this morning, natural history studies are the bread and butter to establish this pipeline forward. And finally, I had the wonderful opportunity to attend last year in November the International Congress for Ataxia Research. This was held in Dallas, Texas. Last year, it was the first ever International Congress for Ataxia Research. We've had the National Ataxia Annual AIM conferences before, but this pulled in Ataxia UK and FARA and NAF all together for the world's largest ataxia research gathering that has ever been had. And I can't tell you how wonderful this was to be back in person with all of our friends, our colleagues, and to build these new relationships forward for research. And we'll be in London in 2024, so exciting. So speaking of exciting news, we have breakthroughs in treatment. There are more clinical trials happening for ataxia than ever before. We have 16 plus clinical trials that are currently in progress. And of course, the most exciting of those are OMAV, that was the first FDA-approved therapy for genetic ataxias. Now, among those 16 clinical trials that are currently ongoing, there are drugs that are regulating glutamate levels in ataxia. They are targeting neuronal misfiring. There are cell replacement strategies. There are protein reduction strategies for those mutant proteins that like to build up in a lot of our cells if you have this disease. There are drugs that are trying to repair the damage that is going on with our DNA. There is mitochondrial health. And so this real gamut of research really started with the cells. It started with the model systems, and it has built its way as depicted here with the Friedreich's ataxia pipeline. And I want to point this picture out because on the National Ataxia Foundation website, there's pipelines for many of the genetic ataxias, and they are slowly progressing, but progressing their way forward to the left or the right-hand side of this pipeline. We hope to have many more in the near future. And you will hear tomorrow Dr. Bev Davidson's talk, actually my former thesis advisor, which I'll be emceeing the Q&A session for, to give you details about some of the breakthroughs in research that has really formulated her career around the ataxia programs.
So next we're going to chat about some of the breakthroughs in clinical care and trial design over the past few years. We're going to start with a big change that happened during COVID, remote care. Now, remote healthcare existed before the pandemic, but in a much smaller capacity. But due to COVID, healthcare needed to adapt. And this resulted in many more options for remote healthcare appointments from the comfort of your own home. You can now even participate in clinical trials without ever having to leave your house. This isn't going to get rid of in-person appointments entirely, but it's great to have flexibility and it's great to have options. Part of the reason that clinicians have been able to offer remote healthcare and remote clinical trial participation have been the advancements made in wearable sensors. These are devices you can wear on your wrist, your ankles, the core of your body, or a combination of these places that can give clinicians information about your ataxia symptoms. This can include small things like the angle of your feet, the distance of your stride, and more. Here's a poster from IDEA, or the Instrumented Data Exchange for Ataxia study that's being conducted right now, examining how wearable sensors can be used to measure ataxia symptoms in SCA 1, 2, 3, 6, and Friedreich's ataxia. Some of you here may already be participants in this study. Wearable sensors will give us better information about ataxia symptoms and when they happen, which will be super useful to know when we're designing future therapies and support. Another breakthrough in ataxia research has been biomarkers. So just like how wearable sensors can measure how ataxia affects your movement, biomarkers can measure how ataxia impacts your body, your brain, and your cells. Finding good biomarkers is super important for future clinical research, as this is one way to prove that a new treatment works, because you're able to measure something that's going on inside of the body. There are so many different research teams that are trying to find the best biomarkers for different types of ataxia and different circumstances. Here's just a few of them. So there's the National Ataxia Foundation's Clinical Research Consortium for the study of cerebellar ataxia, which is a mouthful to say. There's the ReadySCA Clinical Trial Readiness Study for SCA 1 and SCA 3, the BioSCA study at the University of Michigan, the European Integrated Projects on Spinocerebellar Ataxias, the Ataxia Study Groups, RISCA and ESME studies, and as mentioned earlier, the Ataxia Global Initiative is coordinating the sharing of ataxia research from around the globe. So biomarkers, as mentioned, these are part of natural history studies, which tell researchers how different types of ataxia progress over time. So the natural history studies of today are going to help us plan for the clinical trials of tomorrow.
Okay, and so we also wanted to touch briefly on the breakthroughs in research and diagnosis. And so the genetic testing and genetic diagnosis, the cost of genetic testing and the opportunities has definitely significantly decreased over time. There are now new CLIA-approved tests and many more that are being developed. We heard about earlier this morning the free genetic testing for SCA 1, 2, and 3 currently offered by National Ataxia Foundation in collaboration with the University of Chicago Genetics Service Laboratory. This is an incredible opportunity because, again, these are rare diseases that have been stymied by just the conglomerate of our research participants. The more we know, the more opportunity we can create, and we need the patient populations available for us to be able to push these therapies forward. And so at this time, the genetic counseling and testing program is available for those that are 18 and above that have a familial relationship with a confirmed genetic diagnosis. So check out the National Ataxia Foundation website for further information. Additionally, I wanted to speak towards really the breakthroughs in research, defining research based on the genetics. And so what this picture on the slides depicts is the difference between short read and long read sequencing. And what this means for the average American here, or the average worldwide viewer, is I akin it to something like a puzzle. So it's easier to do a 4-piece puzzle than a 1,000-piece puzzle. And so the more opportunities that we can capture more information in a smaller or one piece at a time, the bigger opportunity we have to really decode these genetic ataxias, which currently, as we heard earlier, over 70% of ataxias do not have a genetic diagnosis. That is unfathomable, and without the target for you to aim at, it's really a challenge for these patients to seek opportunities. So, in the last half decade, the human genome has now been decoded with these long-read sequencing. Scientists are able to explore these newly undocumented areas of the human genome and look for discrepancies in our disease population, and in this case, for ataxia patients. And so just to speak towards what this has meant for ataxia gene hunters, which is a fancy, we should give them a hat for that. They've really brought about new discoveries, which we had kind of a lull in ataxia research genetic diagnoses, but now in the last few years, many new genes have been identified. We have heterozygous stub mutations that are, again, rare and now account for SCA48. We have SCA49, which is an SAMD9L mutation. We have SCA50. We have a brand new research that has identified 2 additional genes, like Canvas in the RFC1, which is a recessive ataxia. And more recently, and one of the SCAsources that we highlighted here is 2 publications that came out, and they were the breakthrough sessions at the ICAR last November, speaking towards this dominantly inherited ataxia, which was previously uncovered, so SCA27B. And so I encourage you to check out opportunities to read more about these exciting new opportunities, but I am here to hand over the stage to our guest speaker, Bill Nye, to speak about his experience, his family's engagement in ataxia, and a little bit about what this new discovery means. Please.
Greetings, everyone. You may know me as SCA27B. I was really excited about this until a few minutes ago. Somebody came up to me and said, "Is Bill Nye your real name?" And I said, "It's William Nye." And he said, "Well, why did you change it?" Okay, all right. I thought this could be a long time here. May I just sit with you all?
Oh, of course.
Sorry, I didn't know. So, hi, everybody. I have an older brother and sister, and I have several people on my father's side of the family that have ataxia, and now I know that they have SCA27B. Yes, and so just something about, as you may know, I'm a mechanical engineer. I mean, I'm human, but I'm a mechanical engineer. And I am not a medical professional, but I think we can claim a science educator. And I did a podcast, and we had Jennifer Doudna on it. And she's one of the, how many people here have a Nobel Prize? Anyone? Sure. So does she. And she's one of the researchers that discovered this ability to edit or change genes with a protein. And a protein, writ large, is a molecule whose chemical properties are affected by its shape. Would you guys go along with that? By its structure?
I'd say that's accurate.
Yeah. So it's not just a molecule, it's a molecule that has a shape. And so anyway, they found a way to have this protein go along the DNA sequence and change it. And so we are living at this extraordinary time where we may be able to understand these things and then change them. I mean, this has never been possible. So it's really, it's amazing. And, you know, as the saying goes, I didn't make up the saying, if you couldn't pick where on earth you would be born, there's some rule. Now, is anybody, there must be some lawyers here. I own this hypothetical, okay? We're not going into the future. If you couldn't pick where you could be born, but you could pick when, this would be the time you'd want to be born. As messed up as things seem to be in so many ways, things are actually less messed up for fewer of us than ever in history. And so this gives me reason to be very optimistic about the future. But along that line, we all have to work together. There's no substitute. You know, when my family has this SCA27B, which is cool. No, it sucks. But it is a dominant one. And so you may be able to figure it out more easily, right? But what we're looking for is these, I would call intersections of a Venn diagram, right? We have, these people have these symptoms, they have this genetic sequence, these people have these symptoms, they have that genetic sequence. You're looking for intersections where you can try to find correlations. And then the ultimate is to take correlations and make them into causations, where one thing, you can show that one thing proves something else. And then you can try to address it in any way you can, either from the outside. My sister, for example, is wearing all these crazy weights with a vest that somehow triggers something to help her keep her balance. And then the other thing, and what may seem like an unrelated story, my nephew is a chemical engineer, and he mass produces drugs. And the way the term they throw around is a molecule. Yeah, we're looking for a molecule. That's what we're looking for. Let's get this molecule and make a bunch of them, these molecules. So we're living at a time where we may be able to integrate these two therapies. The external thing, putting pressure on your nervous system in the right place, or taking pressure off in the right places, and with efficacious molecules that do something that we want them to do. And so with this in mind, everybody, I mean, I grew up with these family myths. Have you been through this, where it was believed that men could not pass it on to daughters? Which is absolutely not true. I can tell you that no. From one sample size, I'll tell you no. But there's something where the sequence is shorter in men, when men pass it on, rather.
That's true.
And so there's something to the family myth. And I mention this because what we want to do is gather all the data we can. We want to get all the family DNA sequence that we can, and all the symptoms, analysis of the documentation of the symptoms that we can, so that we can try to find causation for the correlations. And so I will say to all of you, don't make me come over there. Fill out your consent forms. I don't want to have to, I don't want to have to get into it with you all.
Please.
But the idea is there are people who say to themselves, well, I don't want to know because it's too creepy. Okay, fine. All right, but what is it we start complaining about from, pick a number, when we're 14 months old, as soon as we can articulate anything? That's not fair. That's not fair. What he's doing is what my brother's doing. My brother is looking at me. That's not fair. Okay, dude, cool it. By that I mean, please fill out your consent forms so that researchers can look for these correlations and we can come up with treatments to improve the quality of life for people like my brother and sister. And I'll tell you, I won't be surprised, having spent time with guys who may have proven that ancient dinosaurs were warm-blooded. You know how you do that? By looking at neutrons in protein. Of course you do.
Yeah, of course.
Who couldn't do that? Talking with Dr. Doudna and working, not kidding, paleontologists who study dinosaurs. They're looking for these tiny bits of evidence, these very small correlations. And by finding them, we think we will be able to have treatments. And just look at it this way, everybody. Most people here have kids or grandkids or nephews and nieces and so on. We want to make life better for people in the future. And this thing that happened is that the 2 papers were published in December, but when was the breakthrough?
So they were discussed at the National Ataxia Foundation. They've researched and they were in the midst of being published, but they were both quite
They were neck
consistent.
and neck.
Yeah,
So it's long November, December.
One was very genetic heavy and one was very clinical heavy. And so it's a very nice mixture of the depth of research that you can
And with
have.
these correlations, yeah.
And it was asking the simple questions of the when, where, why, how, what. Simple questions that we ask ourselves every day, but if we don't have enough answers to really compound, or enough information to compound those questions, then we won't be able to move this forward. And in those 2 papers, they were able to pull out 200 plus patients that have this repeat expansion. That's not including your family. There's no US family members within these 2 publications. And so I think it's going to be quite a unique experience to watch this field grow with the support of
There's almost 8 billion people on Earth. So to get a sample from 200 is pretty small.
Yeah.
From late onset ataxias that were undiagnosed. So we're a rare community, but I think that shows that those were part of this waiting to be looked into. So those that are still waiting for their turn, their target out there that we want to look into.
What we want to do, as I understand it, everybody, is get all of these studies together so that we can lower the cost of testing.
A meta-analysis.
Is that right? Yeah.
And a CLIA approved, so those genetic counselors, genetic testers out there, please.
Then more about me. So I had one class from this extraordinary guy, Carl Sagan, back during the disco era. And he started the Planetary Society. And I'll just tell you guys, you're both young, just careful. So I was on the board of directors and I left the room and they took a vote. And now I'm CEO. Like stuff could happen.
When you're not looking.
Careful, yeah. So I took this job because, as you may have heard, the U.S. and the world is pretty divided right now, politically. But when it comes to space exploration, people work together. People who otherwise would not get along about anything agree that funding space exploration, exploring the cosmos, is a worthy use of our intellect and treasure. And people agree that studying genetic conditions, and specifically ataxia, is also a worthy use of research funding. So one of the founders of the Planetary Society is Carl Sagan, a guy named Lou Friedman, who was an orbital mechanics, he still is, orbital mechanics guy at Jet Propulsion Lab, and Bruce Murray. And Bruce Murray was the head of the Jet Propulsion Lab during the 1970s, during the Viking and Voyager missions, these famous spacecraft, they're still flying. And he used to say all the time, people ask him, why are you guys exploring Mars? Why are you sending a mission to Saturn? Why are you studying ataxia? What are you going to find out? We don't know. That's why we're doing the research, to make discoveries, and dare I say it, change the world. So everybody fill out your forms. I'm telling you, just fill these out so that researchers like these two can get her done. So that's what I have to say about this. Is that too much? Did I blow it?
That's perfect.
No, you were amazing.
And you're going to be around for
Yes,
later.
I'll be at the Birds of the Feather for any SCA 27s. Woo! And we'll talk about things. Does anybody have questions? Is that something we do here?
Yeah,
we
so
totally
let's
can.
bring up Dr. Moore. And
Oh, cool.
We're going to have a Q&A.
Do I sit here or do I move?
You're welcome to stay if you
Or we're
like
going to
to
run
join
out of
us.
chairs, people.
Oh, I think it's,
All right.
it's just one.
Yeah.
Here, you get toward the middle.
All right, thank you. All right, so we
we do have quite a few questions from the audience, and I encourage anyone. There I am. We do have a couple questions from the audience, and I encourage all of you to continue to put questions in using the Chime app.
Okay, you're the questioner?
I am.
So we got to trade.
Okay.
Sorry.
Musical chairs, yeah.
No, so you guys, maybe you watch a talk show? Jimmy Kimmel, Jimmy Fallon, Stephen Colbert. The host is on the right, and then the guests are on this side. Do you know why?
Why?
Nobody knows why. But you guys may remember Pat Sajak. He had a talk show for about 15 minutes, or 6 weeks or something, and they tried to reverse it. It just didn't work. And I don't know why, man. I don't know. Back to you.
All right. So one of our first questions is, why was it called SCA27B instead of SCA50? And I'm going to direct this to Hayley, actually.
Sure. So in the 2 papers that are published out there right now, one group did claim it as SCA50. As we know, there are a continuing number of SCAs that are being diagnosed or discovered. But it turns out we call it SCA27B, which is really cleverly named because it happens to have this mutation within a gene, this FGF14 gene, that already was characterized for ataxia. So point mutations, single base pair DNA changes, were already described and noted as SCA27. Now, because we have these repeat expansions within the SCA, or this FGF14 gene, they cleverly added an A and a B, and that is the story.
So what should we be getting in fistfights with the 50 people?
No, it's in the middle. You'll be fine. Actually, there's a fist fight already out there between 2 groups that wanted 50 as well.
They're going to argue over the branding a little bit.
Well, it does make a difference, though, because when we go to argue in front of U.S. Congress, for example, we want a consistent story.
Yes.
So what do you want me to tell people?
So nomenclature is key. So there's OMIM. It's a website which is basically a worldwide nomenclature, which is a fancy term for saying we claim this name and copyrighted it. And in this case, SCA27B is what is appropriate.
All right. I'm going 27B. Cool.
Yes.
Yep, and
Approved by Bill Nye.
Actually, since this SCA27B was identified, there's actually been a couple more discoveries. So there will likely be a new SCA50, a new SCA51.
Oh, yeah. Stay tuned.
Stay tuned. Next conference, y'all.
Next conference, we'll give you an update.
In Orlando. Maybe.
Yeah. And Bill, if you're comfortable, would you tell us a little bit about how your family was involved in the discovery of SCA27B?
Well, back in the 1900s, we went to Johns Hopkins in Baltimore, and we were involved. I understand Amy Bastian's not here, but Sarah Ying is here.
Yeah, Sarah.
So these 2 doctors who run a lab, I call her Amy. Dr. Bastian is still there, and they have you walk on treadmills, they have you move your hand with the red light, and they're trying to see the nature of our symptoms. My brother and sister have it much more strongly than I do. This afternoon, if you guys are still here, we're going to show 5 minutes of this movie called Bill Nye Science Guy. I don't know how they came up with that. It's a freaking amazing title. But there's 5 minutes where I'm going on about ataxia. And if you're watching, it came up at lunch today. If you're watching, you can see my sister standing with her feet apart when she was 10 years old. So I think this thing, she's standing in a way that most kids that age don't stand. And I've wondered all my life when it starts and how it progresses. So my sister has tremendous mobility issues. My brother has it coming on. And I watched my father, his symptoms get worse and worse as he went on, and the stress that it caused, the anxiety it caused him. He was a salesman. He would travel around. This is back in the day, people, before the electric internet. He would drive around in a car that didn't have air conditioning in the Washington, D.C. area. You know, it's 99 Fahrenheit, 99% humidity, and it was pretty, people could tell, would wonder if he had a drinking problem because of his mobility issues, and so then he'd start walking with a cane and this and then he ended up in a wheelchair, you know, in his 80s. So I've watched it my whole life. I've been very aware of it my whole life. And I never had kids because I was afraid of passing it on.
I think that's a story that many people in this room can relate to, including myself, coming from an ataxia family. So
there you go.
Thank you for sharing.
Well, sure. And so the other thing I'm seeing about my sister now, I just saw her last week, is the isolation. She's the loneliness that she's experiencing with not being able to just hang out. But mobility is key. Mobility is really important. All right, thank you, Bill. Really, yeah. So we're working on that. Back to you.
All right, I have a couple gene questions that don't relate to SCA27B, so I'm going to direct those to Hayley and Celeste. So for a couple rare ataxias, actually for most rare ataxias, recessive ataxias, there's multiple names for each of these diseases. So for example, ARCA3 is the same as SCAR10, I believe. So why 2 names when nomenclature is so important?
So we've actually just had this conversation last night, you and I, Lauren, about what kind of nomenclature should we stick with? Because unfortunately, there are a few different types of nomenclature out there. If we could all agree on as a community, which one to stick with, that'd be great. And if not,
we're going to stick with what? Sorry?
If we can all agree as a community which one we're going to stick with, that would be great. But there is OMIM, which is what I normally go to, ORM. And then, Lauren, you were talking about a different one yesterday, that it just makes it challenging. I absolutely agree with you.
It's a good problem to have, though, because some of these problems arise from different countries having different names for these diseases, and the fact that we're all working together now has really highlighted how we have to work together and come to terms on.
So my family, there's, my last name is Nye right now, which is a corrupted Danish word, but there's another group of the family called the Darbys. And this condition in my family was called the Darby glide. And the word glide is kind of a charming way of saying you just fall down and break stuff. Yeah. And so I grew up with the Darby glide, was this mythic thing, which we now call ataxia. So the names are important, but I would say, as I say all the time, words include more than they leave out. So if there's space in the paper, use all the words.
That's true. So for instance, what my laboratory specializes in is SCA3 research, which is also known as Machado-Joseph's disease. And that is because of the founder.
And the word disease has always bugged me, you guys.
How so?
Well, I think of an infection.
Okay.
Yeah, I mean, since I was a kid, I've been confused. But I'll roll with it. Yeah. I mean, heart disease, okay, all right. It's not an infection, usually, right?
In neurological speak, I think it is a slow progressing infection here. So we have a progressive disease for ataxia for many of the families that are here. So I think that it's an apt description, but it's not as necessarily, it could be caused by the environment, it could be caused by genetics, it could be caused by an insult from autoimmune challenges that we have. So it's a unique.
So when you say insults, you're talking like if you got an infection as a kid kind of thing?
Yes. Yeah. We have autoimmune ataxia patients that actually we had a few that were in the Birds of a Feather session this morning, and that was quite unique to hear about them. And actually at the ICAR, for those that follow the research programs, we had a whole session, half-day session, that was just eye-opening for those that work on the hereditary ataxias. It's really unique to hear about these different sorts of insults, basically.
I am convinced, anecdotally, small sample size, that stress is a huge effect. Things when people in my family are worried about stuff, their symptoms are greatly exacerbated.
Stressed or not sleeping well,
They can all contribute
not moving
to it.
as much. Yeah, we all know that those are main contributors to progression. So we want to make sure we're staying active, sleeping well. We talked about that actually at the Birds of a Feather this morning, as much as you can, finding ways to kind of manage your stress. And a lot of that comes from finding your community. And that's why we're all here. We're finding our people to lean on and understand our situations and those that are caretakers, both as patients or as caretakers. There's stress that surrounds you in your daily life, and you said this about your father and how that with your whole family.
My father also was a prisoner of war in World War II. He was captured from Wake Island, if you've ever even heard of the place, middle of Pacific Ocean, nowhere. So he spent 4 years, longer than anybody else from the U.S., as a prisoner of war. I'll just tell you guys, if you get a chance to be a prisoner of war, I wouldn't do it. I mean, it's.
Sound great.
I think it's a drag. It's stressful. Yeah. But my father, I'll claim, my father was very funny. I don't have that. I'm just funny looking. But I claim that his sense of humor enabled him to get through it. That's a claim. You can evaluate. Some of what I just said had jokes in it. You'll have to decide where they were. Back to you.
All right. Well, unfortunately, we have run past our time.
What? Don't we go till the top of the hour?
We have another speaker.
We do.
Oh, gee whiz. I'm sorry, you guys.
No, it's all good.
Well, we get to hear from you later,
Yes.
right?
Yes, we're all
and
very
again, please reach out. All these topics, we're very excited to share all the breakthroughs, but there's going to be so many more. And I hope one day you'll invite us back up to this stage, and we'll talk about all the exciting things that are happening.
The breakthroughs. Hey, thank you both very much. Thank you, all
Absolutely.
three, very much.
Thank you.
Thank you so much.
Thank you.